today's speakers. Sarah Soutoul is originally from France. She started her career as a software engineer in the media publishing industry, where she worked for 3 years. Shortly after, she transitioned into technology training and curriculum development. For 3 years, she was a software engineering trainer and curriculum developer, helping others secure their first roles in the tech world. She was able to enter the tech industry thanks to a mentor who opened the door for her, and she hopes to do the same for others throughout her career. This passion drives her most within the field of educational technology. Currently, she continues to teach people online through tutoring platforms like Preply, and she also works as a Product Enablement Manager at Level Access, an accessibility-focused company in the United States. And our second speaker, Celena Toon, currently lives in Boston, Massachusetts, USA. When she was young, she enjoyed making simple websites about her hobbies and customizing the CSS on her Xanga and MySpace pages. However, she had no idea it could be a career path, nor was it ever presented to her as an option. After graduating with an anthropology degree and then happily working at a lab for a few years, she made a transition through a coding bootcamp. She's now worked as a software engineer for the past 8 years at companies in various industries such as biotech, agriculture tech, and government consulting. In her free time, she likes to cook, play video games, and volunteer. Through her volunteer work, she hopes to empower other women, minorities, and underrepresented people like herself to transition into the career they want. She currently works as a senior front-end engineer at Electric AI, a software as a service IT operations platform for small and medium-sized businesses. Sarah, Celena, you have impressive backgrounds both, and it's an absolute honor to have you with us today. The stage is all yours.
Thank you, Violina. So I'm just guessing we're going to start with me, right, on modules, or is there an order that you like to have?
Yeah, I think.
Yeah. Okay. Perfect. Amazing. Well, thank you for the amazing introduction. I'm really excited to be here, and I discovered this organization very recently, so it's really cool that I'm already involved, and I found everyone really inspiring. So thank you for having me, and I'm gonna share my screen now. And as Violina said, we are gonna be basically diving into modules and how do you take a modular mindset when it comes to building your applications. So there's 3 questions I'm going to answer. First one is, what are modules? Second, why are they crucial to building apps that are scalable and maintainable? And then finally, we're going to look at how we can implement modules in your projects. So how can you refactor your projects to be using modules? So I like to start with a simple analogy to make you understand why modules are crucial. Okay, so let's imagine that you are running a busy restaurant kitchen and you only have one big table where everything is happening. So cutting vegetables, cooking dishes, plating your food, washing your dishes, etc., etc. Everyone is working on this single table for everything. Now, that could work if you have a small restaurant. But if your restaurant becomes more popular and you have more clients, more customers, you can imagine that it can become a disaster. And what would be a solution to that would be essentially redesigning your kitchen, where you essentially would have a station for every single purpose that is happening in the kitchen. So you might have a station for cutting veggies, you might have a station for cooking, a station for plating, etc., etc. And that is how kitchens are designed nowadays, as we know. And obviously what happens there is everything is much smoother because everyone has their own role and every station has its own purpose. So why am I telling you about this story? I'm telling you about this story because this is exactly how modules basically work. So if we take it to the actual software. Okay, so how does that work in terms of software engineering? Well, trying to manage all of your logic into one file is basically like using that crowded, chaotic single table. Okay, so at first it might be fine. If your project is small and you have all of your code in one file, it's going to be fine. But if your project becomes bigger, and you have to essentially expand your code base, it's going to become a nightmare. And it's going to become a nightmare in kind of three different ways. First one, in terms of debugging, I mean, we all may have tried to debug an entire file of code, right? Where you have thousands lines of code, and debugging that is going to be extremely hard because it's going to take you a lot of time to find, where the error is, or to understand where, how everything is connected. So debugging becomes a nightmare. Scaling is going to be an issue as well. So when I talk about scaling, I'm talking about, okay, if you first, you start as a startup, you're going to build a very small website. But if your startup becomes more popular, just like the restaurant, if it becomes more popular and you have more clients, you're going to have to expand your website. You're going to have to expand your code base. And this is where issues are going to arise, because essentially, if you don't have a good structure at first, being able to scale up, and by scaling up, I mean growing your code base, being able to do that is going to be hard. It's going to be a nightmare as well if you don't have the correct structure at first. And then finally, collaboration. Okay, when you work on a website, having to collaborate with people is usually something you're going to have to do. And if you have everything in one file, I mean, it's going to be a nightmare to collaborate with other people, on that one file. You're going to end up having conflicts. You're going to end up probably overwriting each other's code, etc., etc. So what is the solution to this? This is where modules basically come in. It used to be, before modules were a thing, it basically used to be like that. Developers used to work like this, where everything was kind of in one file, but it caused a lot of issues. And it caused what we call spaghetti code. Spaghetti code is essentially just a mess, right? As spaghettis are, they all are interlaced. And that is essentially how code was. Now, when modules came in, what happened is basically everything was redesigned to have those single stations, just like the restaurant, where each station has a specific purpose. So that's what modules are. Modules are basically these different files and these different pieces of code, and each piece of code has a specific purpose. And the point is that with modules, you're not able to organize your code in these different, isolated parts that can then communicate with each other. But the benefit is that now everything has its own purpose and has its own place, just like your restaurant station. And so modules really transform the way that we, write JavaScript. It turned this kind of chaos, this disorganized chaos that I described to you, into something more maintainable and more structured. And so we're going to look at, obviously in details, at how modules look like, but I just wanted to offer to show you basically why we had this switch, right? From kind of disorganized code to more structured. So how did we get here? We're going to take a step back and we're going to look at how things used to be. Okay, so I call this the script hell. Essentially, before modules were a thing, JavaScript had no kind of official way to organize your code. So what happened is that developers would basically have this several JavaScript files, and they would have to basically load every single script in their HTML file. And because obviously HTML reads from top to bottom, this basically raised a major problem. Can anyone think of the problem of this? I'm gonna be interactive here because I like to ask questions. So if anyone wants to unmute or put in the chat, but what do you think the issue of this is or can be in the long term? Come on, Lauren, you got this. I'm picking on my tutti here, who is in the call. No, Agatha?
Maybe like if you have a function that is calling something else, it will call it like at the wrong time or something like this, like a callback function or event listener. They will not be able to talk to each other.
Yeah, that's kind of it. So basically, what's happening with a setup like this is, let's just say that app.js needs a function that is defined in utils.js. You have a function defined in utils, and you need to call it in app.js. Because a HTML file reads from top to bottom, if you switch the order of this, then suddenly your app is broken because utils would have been loaded after app. And obviously app needs something from utils. So it means that here, the order of which you load your scripts is extremely important. And as the developer, you need to be aware of that, and you need to make sure the order is respected. Now, again, it's fine if you have a small app. It might be manageable. But as your app grows, you can imagine that it becomes extremely difficult to have to respect this order. And you're going to make a mistake at some point. You might misplace a script. You might mess up the order, and that's going to break your application. So that's the first problem. Second problem is going to be around what we call global namespace. So with this setup right here, if you define basically a variable or a function in one of these files, it's going to be available in the global scope. By global scope, I mean it's going to be available to the entire project. So what did that lead to? It led to basically two files declaring a function with the same name. What would happen is that they would overwrite each other. Okay, if you had a calculate function in one file and a calculate function in another file, you would have that overwriting, and that would cause some issues as well. Finally, we're talking about maintainability. So with this setup right here, being able to maintain this can become difficult, again, because of debugging and what I talked about previously, because you have all these dependencies to kind of manage. So this is how it used to be. And obviously developers were like, wait a minute, we can't continue like this. And we need a system that is much more structured, that is organized, where I'm able to basically share functionality between files, and I don't have all these issues that I've just described. So this is where modules came in. And modules are basically this kind of, like I said earlier, this kind of self-contained, isolated blocks of code that encapsulate functionality, so that contain some kind of functionality. The best analogy I can give you here is Lego blocks. Okay, we've all played with Legos when we were younger. If you take a Lego piece, that serves a single purpose. And if you take another Lego piece and you put them together, you're able to build something. Okay, so with Lego pieces, you're able to build a house, a spaceship, a castle, whatever. Modules work exactly the same. You're going to have these separate modules. Each of them have a specific purpose. But when you put them together, you're able to build something larger, like an application. Okay, so remember that analogy of the Lego piece, because I think it helps a lot. And if you've dealt with React before, it's exactly the same system, okay, with components where you have these different components that are self-isolated. And when you put them together, you build something bigger. Okay, so it's exactly the same thing. Now, in terms of benefits of modules, I'm going to kind of brush through this because we've referred to them already. But reusability is huge. If you build one module, like one function, for example, you're able to reuse that function across different files or even across different projects. So you're able to reuse a lot of your code. Maintainability and scalability. If you have these smaller kind of build pieces that are more focused and have a specific purpose, being able to scale up your project is going to be much easier, and being able to maintain it, so debug it and test it, is going to be much easier. And then finally, we have namespace isolation, and this is the big one. I talked about how with the script hell previously, you had this global scope and things would conflict with each other. With modules, the nice thing is, whatever you define in a module, and when I say module, I mean a file, whatever you define in a file is going to be only existing within that file, okay? So it's going to be defined within that file, and it cannot be accessed by other files. And that's good. That means the scope is narrowed down and you don't have these conflicts. Obviously, modules allow you to then share functionality. So if you have a function you want to share with another file, you're able to do that. But if you don't put that in place, the scope is basically isolated. And that's why they are self-contained blocks, okay? So this brings me to, that's great. We have this self-isolated pieces. How do they communicate with each other? And this is where the concept of exporting and importing comes in place, okay? So when you have these modules, you're able to essentially share functionality or data across these files using exporting and importing. And they are two things that need to happen together. Exporting means you are in a file and you have a variable that you want to make available to the rest of the application. Therefore, you're going to basically export. Export means making something available for use in other files. Importing means, okay, I'm in another file and I want to grab this thing that I need from another file. So I'm going to import it. I'm going to get it into my file, okay? And they go together because you need to export first and then you need to import. So that's essentially what modules kind of allow you to do. Now, how do we do that? How do we implement modules? So I'm going to take a bit of a step back here and show you it's important to understand the evolution of JavaScript so that you understand why we implement modules the way we are today. So here we're going to talk about CommonJS. So very briefly, JavaScript was used previously, initially for a browser. Okay, so it was like front end really focused. But by the late 2000s, basically JavaScript started being used in server-side programming. Server-side is backend, okay, with Node.js, if you know about Node. And so what happened is that now JavaScript was used basically in both the client and the backend. However, programmers had the same issue. They couldn't organize their code in different pieces and they couldn't bring that functionality. Why? Because JavaScript didn't have a built-in module system. JavaScript didn't come with this ability to build modules. So what happens is CommonJS was created. CommonJS is a module system that was created as part of Node. And it was great because it offered the ability for backend developers to do those modules. However, the problem and the limitation of CommonJS is that it is not supported in browsers. So if you try to use CommonJS in a front-end application, it is going to throw an error because it is not natively supported in the browser. So what happened is that front-end developers had to find some workaround. One of those workarounds was using some additional tools that allow you to basically convert like CommonJS syntax into something that the browser could understand. And that was fine, but it wasn't great, okay? So that was the first step in bringing modules, but it didn't work for the browser. It only worked for server. And in terms of the syntax, just kind of showing you briefly, this right here is how to export with CommonJS. So you have, let's say here, two functions. You want to make those functions available to other files. So you're going to use module.exports, and that's the syntax. On the other side, in app.js, where I'm showing it here, you trying to access whatever was just exported, you're going to use require. Require is the word to import, okay? And that is the syntax for CommonJS. But as I said, it was not the ideal solution. And this is where the powerful ES modules came in place. And that was around 2005, 2006. So this is when JavaScript became even more powerful because basically a native module system was created, not just for server side, but for browser environments as well. And that was huge because now we could basically use modules without the need for additional tools in a front-end application, okay? In terms of the syntax, you have it here. So right here, so this is the same code than the CommonJS, but you can see that it's a different syntax. So here to export a function, you just need the word export in front of the function that you're exporting or the variable that you're exporting, because you can also export a variable. On the other side, you can therefore import whatever you need. In this case, we want to import add and multiply. And so we're going to use import. We've got our curlies, and then we've got the stuff we want to import inside. And then you've got your destination. Where is that thing from? Okay, so that's the syntax, and I'm going to show you in the demo how it works. But you can see that this first is much more easy to use, it's clearer. But the big one is you can use that in your front-end applications, and that's great. So I'm going to actually go out of the slides now to show you the live demo. And we'll do questions if there's any afterwards. So let me just get this here. And I'm just going to open this here. Okay, so this is a very simple application, okay? But as you can see, all of the code is in one file, is in app.js. This code right here, what does it do? It calculates basically the total like price of these items, including tax. Okay, so you have these items here, you have this calculate total function, and you have this format currency function, which basically formats the result. Now, it's all in one file. And it's small, right? So technically you could stay with this, but I'm trying to give you the modular mindset here. Okay, if I were to grow this application, how would I make sure that I have that structure in place from the get-go so that I can scale up this application? So I'm going to basically go through this with you and refactor it. Obviously, you don't have to follow along. I can send you the code afterwards. So if I look at this, I'm like, as a developer, okay, how can I refactor this in modules? I need to look at this and think, I need to look at the different purposes, okay? So I can break this down by looking at, okay, what does each of these pieces of code do? And can I put it in a module that has that specific purpose? So looking here, I can see I have some data. Boom, that's one purpose, okay? That's a module right here. Then I have a function called calculate total, which calculates my total. So this is some logic around calculation. Boom, second purpose. I can put that in another file. This right here is around formatting. Third purpose, and I could put that in another file. So with this code, we have essentially 3 files now that we can create to separate our code into modules. So what I'm going to do is I'm going to create a data.js file. I'm going to create a calculator.js file, and I'm going to create a formatter.js file. That's the first step. Now I'm going to have to transfer code over. Okay, so I'm going to start with data. I'm going to take all of my data here, and I'm going to copy that, go into my data.js, and I'm going to paste it here. Okay, at this point, if I were to run this application, it would break because I've just transferred some code over, but I am not doing any exporting or importing. And like I said, there's no global scope. This is only defined in this file and this file only. So if I go back to app.js, this right here, this items and tax rate data is going to be undefined if I try to run this. So I need to make sure that it's available for use so I can import it here and use it. So how do you do that? You're going to use the word export, like we saw in the example. So what I can do is I can put the word export in front of the items that I'm trying to export. And that's great. Now they are available for use to other files, and I can just import them wherever I need. This is one way of exporting, by the way. You can also export like this. Okay, I'm going to show you both ways. So you can also have it at the bottom where you would have your curly braces, and you would then pass the things that you are trying to export. In this case, items and tax rate. So you can do it this way, or you can directly do it on the thing you're trying to export. There's no massive differences between these two ways, by the way. You can choose the one that you prefer. Like some people like to have all their exports in one place, and some people like to do it directly on the thing that you're trying to export. Okay, so now I'm going to do the same for the rest. So I'm going to take my calculate total function, and I'm going to transfer it onto calculator.js, and I'm also going to export it. So I'm going to put export function, or you can export it at the bottom and have it like this, okay? 2 ways work. I'm going to keep it like this. And then finally, we have our formatter. So I'm going to transfer that over here and do the exact same thing where I'm going to export. Okay, so now I've moved everything. I've exported the stuff that I need to use in app.js. So that's great. Okay, now before I move on to the next step, I do want to explain something. What we've used so far is what we call named exports. Name exports are basically when you're trying to export multiple things in a file. Okay, so for example, in data, I have two variables and I'm able to use a named export to export those variables. But on the other side, when you're importing, you have to make sure you are using exactly the name here that we have set up, okay? So that's what name exports are. They allow you to export multiple things. Now, there's another type, which is called default exports. And these are when you are trying to export one single primary functionality from a file. Okay, so the way it works is you're going to have export default function, for example. Let's just say we had another function. But the key here is, you see, we are using the word default. Okay, what does that mean? It means that you are setting this as the default export of your file. So on the other side, when you are importing, you could literally say import banana from calculator.js, and it would know exactly what you're talking about because it would basically defer to the default export. Okay, so the naming on the other side doesn't matter. You can call it whatever you want. You don't have to say import say hi. You can use any name, and that's because it's the default export. But like I said, this is for a single primary functionality. What this means is you cannot have two export default in the same file. Okay, so this is primary use anytime you are trying to export one thing from your file. That is going to be the primary kind of functionality from that file. You can have named export and default export in the same file. That's completely fine, but you cannot have two default exports. So hopefully that makes sense. Okay. So I'm just going to leave it here, actually. Actually, let me just make this default because we have one function here. And that way you can see the difference in terms of importing. Okay, so now that I've done this, I'm going to go to app.js and I'm going to import my things. I'm going to import my variables first. So to import, I need the curly braces because these are named exports. Okay, so if it's a name export, you need the curly braces. And I'm going to put the destination, which is, in this case, data.js. I'm going to do the same for my format currency. Import, again, curlies, because it is a named export. And automatically it's giving me the destination, so that's great. And then finally, I'm going to import my calculate total. But remember, this is a default export now. So I could just say import calculate total from calculator.js. But as I said, it doesn't matter the name you give it. You could literally just say calculate from calculator.js, and then you replace that in your code, obviously. Okay. But it knows right away what you're talking about. It knows that you are referring to this right here because you have this default. Okay. So nice, that's great. We have everything imported. And at this point, you might think, okay, things should work. No, things are not going to work yet because you need one little thing at the end, which is refactoring your index.html. So at the moment, it's linked to the app.js in a script tag. Why app.js? App.js is your entry-level file, meaning that everything is happening in app.js. It is the home base where, you know, the execution of the app is happening and you are orchestrating all of these modules communicating with each other. And this is the beauty of modules. Instead of having several scripts, you now have one script and that's it. You're not going to have to add another script because everything is shared with modules. You do need to add a type equal module in your script. That is key. Without this, things will break, okay? You need this type module because this will basically tell the browser, hey, can you treat app.js as a module? And that is going to make sure that you can use the import and export syntax. Okay, so let me show you. I'm going to load my page. And Obviously, it's nothing fancy, so it should just pop up in my console. And of course, it's not working. That always happens. Let me just double check. I may have forgotten something. This is beautiful. Oh, I know why. I forgot my .js here. Okay. Lovely. Okay, so we have a console log. So it is working. We are getting what we should be getting. Okay. Let me just show you what happens when you remove type modules so that you're aware of the error. So if I forget my attribute, this is what we get. Cannot use import statement outside of a module. Okay. So as you can see, this is extremely important. Now let me break something else. I'm gonna remove this items. I'm gonna forget to export items. If I go back, I'm getting an error. The requested module does not provide an export name items. This is super powerful, by the way. The thing with module is that it's going to give you errors like this, and it's going to tell you right away if you've forgotten to export something. Okay, so have your console open at all times if you're using modules, because it will be super useful in telling you what's going wrong. Okay, so that's it really. I've been able to now refactor my app, and you can see it's much more structured. Everything has a purpose. You know, this is the data, this is my calculation logic, this is my formatting, and then it's all being beautifully connected here. Okay, so that's great. And now, if you were to continue on this project, you can scale it up very easily. If you have another formatting function or variable, you're like, oh, great, I have a place for that. I have a station where I can put my formatting code. So here we go. I'm going to add it here. Okay. And you have the structure in place that is going to allow you to basically grow your code base without having all these issues that I told you about earlier. Okay. So I fear I may have gone over time, but this is the end. So I don't know if there's any questions around all of this from anyone. Just look at the chat as well. No questions? Okay. In that case, I'm going to hand over to you, Celena.
Yeah, thank you. That was really great. Excellent description and explanation of modules. I loved it.
Thank you.
Now I will move on to talking about open source packages and security. Okay, here's my presenter view. Okay. All right, so we will be talking about building with tools and security. So now that you've learned all about modules, we're going to talk about using open source NPM packages, also known as modules, NPM modules. So before I go into talking about NPM and node modules, let's define what a package manager is. So a package manager is a collection of software tools that automates the process of installing, upgrading, configuring, and removing of programs. And NPM is a JavaScript package manager. It allows you to install and manage modules from a public repository for your projects. Some alternatives to NPM include Yarn and PNPM. Different package managers have their pros and cons, and you might see that some companies will choose to use one over the other. Today, we will be focusing on NPM, which is very commonly used and also the default for node projects. And here is the link to the NPM website. I'll show you a little bit of this. So here is the NPM website. And some packages that you might be familiar with are things like React. We'll take a quick look at that. So NPM has all of their packages in a registry, and you're able to go on their website and search for the packages that you want to look at. So this is what the React package looks like on NPM. And there's like going to be a little description, some information about it, like links. And then on the side, you can see an install instruction, and then links to the repository, homepage. And this is some good information here, like weekly downloads, the version it's on, license, files, issues, pull requests, and when was the last time it was published. So this is all really good information, and we'll talk more a little bit about that later on when we talk about how we evaluate packages. And later on, we'll also demo some other packages like date FNS or date functions. You can also find here. And this is all the same kind of information. But when you're searching through the NPM website, you also want to be a little careful. So if you have a package in mind that you want to use, you can look for it here. But sometimes what you'll get is not what you're looking for. So an example is the faker package here. So if you look here, this is the first result that pops up. But this looks kind of strange, right? There's like not a lot of information here, even though faker is a very well-known module or package that's used by a lot of people and companies. And if you actually look at faker's website, you'll see that the link to their GitHub is up here. There's all of this information too, but if you also look at the installation command, you'll see right here that faker is actually called faker at faker-js/faker, which is different from this faker. So when you're searching for NPM packages, you do want to be careful. And if you start typing this, you'll actually find it here. So one thing that I actually do is sometimes rather than going straight to NPM's website, I actually go on Google to look for it. And I like to look for their documentation page before. And then another thing that I will show you is the node module. So when you install packages using NPM, what it will do is install in a file called node modules all of the package's dependencies. So in this example repo that I have, I really only have like a few dependencies here. There's only like 4. But you'll see in the node modules folder, it's all like a lot of different folders. That's because every single package comes with its own dependencies, and all of those dependencies also get installed into your machine. So oftentimes you'll look at the node modules and see a lot of folders, but that's fine. This is actually expected. It's pretty normal. So don't freak out about the huge amount of folders in here. Okay. And let's go back to the slides. So we'll do some package demos. And actually, before I do that, let me show you real quick how do you get NPM into your projects?
Celena,
Yes?
sorry for the interruption, but we see only the slides. We don't see any code.
Oh, sorry about that. Let me reshare screen. Okay. So are you able to see this here? My terminal?
Yes.
And then what about VS Code?
Yes.
Okay, here. So this was the node modules over here that I was talking about. I only have, see if you look at my dependencies, it's only a few of them, but there's a ton of folders here. But I wouldn't worry about that. You can just collapse that and not look at that. So then going back to my terminal, I'll show you if, let's say, I'm going to make a new project. And then I already have NPM installed globally on my machine, so this will work. But I will type in npm init. Oh, first I need to go into the folder, and then I will type npm init. And what this will do, it'll start giving you some prompts. So it'll ask you for a package name, version, do this, entry point, pest command, pest. And I don't have that yet, so you can skip all this. But that's how you initialize NPM into your package. So now I'm in here. What it does is that it creates a package.json folder file. And if we look at that, oh, here it is. So this is the file that it generates. And in here is where all your packages will go. And you'll also have this script section right here These are basically just shortcuts to any commands that you want to use during your project. And I already have a different project prepared for this, so we'll actually take a closer look at this one here. So in order to install your packages, so we'll start with Faker. You want to get the installation command right here, npm install. And at Faker, that is the package name, and then -- save dev. That tells it to save it to your dev dependencies. So I'll just paste that in here. Oh, that was the wrong project. I have that, and then I ran npm install -- save dev. You'll see this, 92 packages, and found 0 vulnerabilities. And my package.json here, I already had Faker, so you'll see it in dev dependencies. So if you've noticed that we have dev dependencies and dependencies in our package.json folder or file, and the difference is that dev dependencies are the dependencies that you need for your development. And these don't necessarily affect your actual visual portion of your application that the user interacts with. So for example, if we're looking at date functions, this is for formatting dates to display to your user. So that is actually in your application. So that would go under dependencies. But Faker, what Faker does is that it generates fake data. It generates mock data for tests or for testing purposes or development purposes. And that doesn't actually affect your application other than in the texting environment. So that can go in your dev dependencies. Okay, so now let's take a look at a Faker demo here. So I just created this little index.html, and I have already a command. I can do npm start. This will start parcel, and now I can access the page here. We'll go to localhost. It just has a little text box. And here in the console is where we'll see the JavaScript once I put that in. So index.js, we'll look at Faker. Okay, so I want to import Faker. And actually, before we do this, let's take a quick look at some of the documentation. So documentation is always very important when you're looking at open source packages. It'll tell you everything on how to get it installed and how to use it. So Faker has 3 types of modules here. It's got modules for basic data types, data type, date, number, and string. Got topic-specific modules like animal, food, and some helpers. And this is all to help you generate mock data if you're interested in testing or if you're interested in generating fake data for your web application if you don't have real data at the moment. Okay, and so we'll start. Have a little bit of this. So let's generate a random name and a random email. And I'm going to console log it here. So once I save this, it'll reload right here. So you'll see random email. I generated philip96@yahoo.com and random name, Edgar. So that's how it works. It's pretty easy to use. We'll also take a look at Faker itself. So you can just console log Faker to see its contents right here. So right here, you can see like airline, animal, book, color, all of these different topics. If you looked at my code, I was importing from, which one? Let's see. I was importing from person and from internet. So faker.person and faker.internet right here. If I go here, you can see here's person, and then you can see like here's first name and all of this stuff. So it's a very, very useful package for generating fake data. Okay. And now we can go take a look at date functions. I'll just delete all of this so we can see the date functions. Once again, make sure you take a good look at the documentation. So here, date functions provides a comprehensive and simple tool set for manipulating JavaScript dates. And this is used a lot. It makes working with dates a lot easier because dates and times are notoriously difficult to work with because there can be so many different edge cases. There are so many different ways you can display a date and time. You can do like month, day, year, or year, date, year, month, day, different formats depending on locale. So that's something that if you were to code by yourself, you would have to code a lot of different edge cases, and then you want to test all of them. But this is already done for you, so you can easily use date functions to handle that. So let's take a look at one of the functions here. Format was, can you search? Format distance, that's the one. So if you look at format distance, it can return the distance between the given dates in words. So this is super useful. Like if you wanted to return less than a minute, just based on date times that you have, you can use this package for that. These are all your different options. Like that. And then down here, we'll tell you how to do it. And then we will actually do it here. So for date functions, whoa, that looked a little weird. Let's do this. And then instance, we want date 1 and date 2. And this should display in about 1 hour. So we'll console.log that. And here, as you can see, it says in about 1 hour. And we'll console log, let's look at the dates too, so you can see what the dates originally looked like. Okay, here it is. So this is what we got for date 1. It's an actual date object. And date 2 is also an actual date object, but if you wanted to get the text in about 1 hour, you would have to do a bunch of math and other things to actually get to it. But date functions makes it super easy for you to just pull this here using that function that they have. Okay. Is there any questions so far? Maybe I'll check the chat real quick. Actually, I can't see it from here. Okay. Well, I'll just go on to the next thing then for the package demos. So we're done with that. Okay. So some additional tips and tools when you're working with open source packages is, I mentioned this earlier, be careful when choosing to download and use a package. So earlier I was showing you the NPM website where when you were looking for the faker package, it didn't give you the result you wanted. And you have to be a little vigilant about that kind of thing. Another thing, before you even choose to use a package, I want you to ask yourself, do you really need the package? So modern JavaScript has a lot of features. In the past, there were a lot of things that JavaScript couldn't do. So there were a lot of packages that were made to kind of fill in those gaps. And for example, one of those was Lodash. Lodash provided a lot of like really useful data manipulation and like formatting type of functionality. But today, modern JavaScript actually can handle a lot of the same functions, so you don't actually need Lodash. So maybe you don't really need the package because every time you introduce a package into your project, you also are increasing the risk of security vulnerabilities and also other things like you also need to rely on that package for their updates and for that package to be up to date with their security and things like that. So if you can avoid using a package, you should. But obviously, with a package like date functions that has a ton of date utilities that you don't want to code yourself, like that is a very good example of when you want to use a package. And another example I can give you that there was some drama back in 2016 with a package called LeftPad. And all it did was provide some padding to the left side of strings. And it was like literally 11 lines in this package. And lots of projects relied on this package just for that purpose. And it included like companies like PayPal and Netflix even had it. And then the owner decided to take it down. And when that happened, those projects just broke because they could not download the LeftPad package because it was gone. NPM ended up restoring it to fix that problem, but that was it. Yeah, that was it was some funny package drama. Oh, oh, here's the chat. I see it. Anna says, I'm reluctant about packages. I don't know. I try to stick to the straight way. Yep, but I do feel like I'm wasting. It depends. You have to make that call. It's good to research packages too. So my next point is that you should use packages trusted by the dev community. And in order to do that, you basically talk to other developers and ask what they're using. And then there's also a lot of resources like checking the stats on GitHub stars, contribution frequency, and number of downloads. So NPM earlier, when we were looking at React, I was showing you this, the weekly downloads. 23 million weekly downloads is really, really good. And they're also they published 11 hours ago, updated it. It's from Meta. Like, it's backed by a company and that they're always making changes and updating it and all of that. So that's how you know like React, and everyone loves React and talks about React a lot, and it's well loved in the community, well known. That's why you know that React is a package you can trust. And over here on this image here, this is on GitHub. This is the GitHub page for React. I'll actually show you exactly where this is. Here, I'll click this. If you look up here, you can see how many people watched a repo and how many forks it has and how many stars. Like this is a really high number, 231,000. Like for unknown packages, the number is going to be really low. Another tip for security is that you can run a command called npm audit in your projects to check for security vulnerabilities. So I'll show you that right now. I'll exit this. Okay, if you run npm audit, I'll tell you, found 0 vulnerabilities in this project. I mean, there's only 4 packages here, but this is super handy for when you have way more packages in your project. And then make sure your dependencies are up to date. So make sure that whatever packages that you are using in your project, that you kind of pay attention to when they're updating and what they're changing. And one of the really useful tools that I forgot to throw into this slideshow is something called Dependabot. So if you're using GitHub, this will automatically tell you when there are updates to packages that you are using, and then it'll actually create a pull request that you can review and then update your package for you. I'll add this as my slide later. But yeah, also Google is really helpful. A lot of times when I'm looking for packages to do specific things, I just go to Google and go to Reddit and see what other people are saying about different types of packages that they have used to serve their purposes. Well, now, before I move on to security, any questions? Okay. All right. So this is a quick intro to JavaScript security. Number one thing that you need to know about JavaScript on the browser is that it is totally public. The browsers download your code in order to run it. And because it has all of that code, you can actually view that code in the source and network tabs. So let me run my app again, and then we'll look here. So if you go here, sources, and right here, the index, that's the HTML, but you see index.js here. Oh, it's actually not this one. Oh, wait, it's this one. This is exactly what I typed in my code. And So remember, when you are typing using JavaScript in your browser, that information is totally visible to people who access your website. Modern build tools these days for JavaScript can obfuscate all of this and make it harder to read, but all of that can be reverse engineered. So you should not rely on that to hide your code. So really important thing to remember about this is that you do not want to put sensitive information on your client-side JS. So things like user credentials, logins, and passwords, keep that. Do not hard code that into your JavaScript files. Things like API keys, you generally want to not hard code that into your files as well. And by hard coding, I mean like straight up typing it like here's my API key. If I save this is sensitive information. You might be perhaps paying for that API key, and if you're paying for like every use of it, someone can go in and abuse that. If I refresh this and then go back to the script, you can now see this. Like, you don't want to do that. Okay. And then, oops. There are some cases where API keys can be used, and that will generally be specified in the documentation. One example of that is the Google Maps API key. So that specific API key is okay to put it into your JavaScript because Google actually rates limits and has other protections within that API key so that it doesn't get abused. And another example of something you want to do is like things like prices. If you have an e-commerce site and you're calculating prices on the web page, and when the user checks out, they could potentially change that information and try to purchase your item for like 1 cent. So you want to make sure on the back end you're also doing things like recalculating that and verifying that kind of information. Okay, and one important thing to know about security as well is cross-site scripting. So what is cross-site scripting? I took this definition from OWASP, which is the, online worldwide, open worldwide application security project. And that is where you should go to for like all of any security for web application needs that you have. Like if you want to learn about security, that's where you should go to. So their definition is that an attack occurs when data enters a web application through an untrusted source, most frequently a web request, and the data is included in dynamic content that is sent to a web user without being validated for malicious content. So I have this little graphic here that I took from Sneak. It shows the hacker sending a malicious script into the web page and the server, and then it gets injected into the website, and then the user accesses the website, and then the browser downloads the website from the server and executes it. And it can result in the malicious script runs and then stealing cookies and other kind of information that the hacker now has access to. So the malicious content sent to the web browser, it often takes the form of a segment of JavaScript, but it can also include HTML, Flash, or other types of code that the browser may execute. These variety of attacks is almost limitless, but they commonly include transmitting private data like cookies, session information, passwords, credit cards, financial, that kind of thing. Like it can be redirected. And then now the hacker has the information from your machine. Open worldwide app. Yep, okay. So some tips about that is that you should always validate and sanitize your form inputs and in general, your HTML. Like the rule of thumb, anytime you are taking data from the user and embedding it in HTML, you must sanitize it first. And there are some packages like DOM Purify, which sanitizes your HTML and prevents XSS attacks. There are some front-end frameworks like Angular that provide built-in tools that will sanitize your HTML. And then over here, I have a link to the OWASP cross-site scripting prevention cheat sheet. And then also over in the little project that I created here, I just wanted to show you like a little example of how it can happen. So I have this little text area, and let's say like I'm typing, and you see how it shows up here. I have it as you type, it will render into some text on the page outside of the text box. Usually in applications, there's a lot more going on with JavaScript running, and sometimes you might also submit this into the server. And if you don't sanitize your HTML input here, I could literally just type, like, I could submit a script, a JavaScript script to do things. And if it goes through and runs, then that's how it can happen. And also, I can do things. This is something a little different. Like if you are familiar with SQL, you can maybe like type like drop your databases, whatever, I forgot, table. That's actually a SQL injection attack, and you don't want that to happen either. So you need to make sure you clean up your inputs before they get sent. Okay. There's a very famous XKCD comic that I should have put in here, but I didn't. Anyway, another tip I have for you is that make sure you're using HTTPS origin. So sites with an HTTPS origin are insecure. This means that people can look. Oh, this is wrong. That's HTTP. I'll correct that. So sites with an HTTP origin are insecure. This means that people can look at the data that you're sending and receiving. People may be watching over a public Wi-Fi network, and so any sort of data that you are sending, like let's say you're trying to log into your bank, and then, but it's an over HTTP origin, and then someone is looking, if you're on public Wi-Fi, someone might be looking into your connection and they can see your request, and like now they know your password and your username. But sites with HTTPS origin, they send and receive encrypted data. So all of that data will be not easily looked at. And this is normally not an issue since most APIs are encrypted, but it is really good to keep in mind. And how do you know if it's HTTPS or HTTP? Very easy. Just go to a URL. Oh, I can't see it here. Okay, my browser has this. Connection is secure, all of that. But usually it'll start with, you'll see like, it'll start with like, if you look at Twitter, that's HTTPS. And also a lot of browsers these days are very good about telling you when you're going into an insecure website. So like I know on Google Chrome, if you go on a website that's HTTP, it'll pop up something that tells you, hey, this website's insecure. Like, do you still want to proceed? So just be aware of that. And then another really good tip is just in general, you should be reading up on the OWASP 10 web application security risks. Just keep on top of that. And knowledge is power for security. And that's all I had about security. Oh my God, it's a little over 12. Sorry about that. I have all the links here on my slides. I can share these out after as well. And that's all.
Hi, Celena, thank you so much. I do want to share and say that not because it's the WAS study group in session, but just because both of you are amazing. It was just unbelievable, very informative session. The hard modules and the hard security NPM packages, you ladies bring it like so seamless. Thank you. Thank you for today. And thank you for being part of our WAST session. I'm going to share a screen, and actually we're going to talk about our JavaScript star contributors spotlights. We're going to say thank you for Anna, Elizabeth, Rora, Uzma, Shruti, and Warren for being dedicated, submitting their tasks, contributing, and being present the whole time. Of course, congratulations to everybody else being staying together to the end of the our JavaScript study group. Thank you and congratulations. Also, we want to say thank you for Frontend Queens for sponsoring the JavaScript study group. Without Without the contributions in so generosity, we will be not able to be here today. And to all the speakers who would like to share their time and knowledge, and to everyone involved. Please do let us know if you have any questions on the end. And now we're gonna open the stage for testimonial. If anybody wants to share their experience during the study group, if anyone want to share what they learn, what they don't learn, and are they gonna keep improving? I'm gonna take a look to see if anybody is open. Please do feel comfortable to unmute yourself and share a few words. On the end, also, we're gonna have a photo booth. This is our last session. We wanted to make it memorial. So I'm just gonna take a look. Warren, Anna, Dipti, Agatha.
I'll go first. I just want to say a few words. Thank you. I'd like to thank especially all the speakers for all these weeks. That it's amazing. And my style of learning, I need some interaction to, to keep going. And it was just so helpful to, having all these amazing people speaking, and everyone has their style of explaining. So we're doing a video course and doing the exercises, and then you have someone else come in and they explain in another way, or they add information that it was not there and you hadn't had contact yet. This session was great, and I just keep learning. I want to thank all the colleagues in this course too, because I felt behind sometimes, and I'm shy about sharing my code, but I see that everyone goes at their pace, and that keeps me motivated. So thank you, everyone, and thank you, Mariya and Violina, for organizing this. It was great, and congratulations to everyone for concluding.
Thank you, Anna. Congratulations really for everyone to being staying to the end and showing for yourself, and for our amazing speakers who are just being so dedicated and with us to the end. If anybody want to share their story, please do feel free to share your thoughts. Yes,
I'd
Lauren.
just like to say thank you, to Front-End Queens for organising this, because being part of a community of learners really helps you to keep the momentum going, keep each other accountable, and to be part of such a supportive group has really helped me jumpstart my learning with JavaScript, and I really want to continue. I hope I can stay in touch with people from the group and we can continue to support each other. So thank you so much.
Thank you, Lauren. I remember the day you joined us. It was a little bit day or two later, and you were so excited. You was texting back and forward, wanted to start the new journey. I remember very well that day, and we are very proud of you. We noticed that you're submitting your homework and tasks. Even though a few behind, you're always asking for review, for support. That was so nice. We're wishing all of you good luck